Well, hello everybody, welcome. Hey, this video is all about bearings, everything you're going to need to know to be successful with bearings. This is the third part of our non-right triangle trigonometry. In this one, we're going to be talking about applications of trigonometry. We're going to use bearings to do that. In the next video, it's going to be real short. We'll talk about the area of a non-right triangle. But here's our game plan. We're going to talk about the three things you got to know, how bearings and angles work, required background knowledge. That's actually the tricky part. Run through a couple of examples and give you some problem-solving tips and clues that will help you when you're dealing with bearings. You can use the timestamps in the description to navigate all these different chapters of this video, but also in the description you will find a downloadable set of guided notes so that as you're learning this, you can take notes. They'll be nice and organized for future reference. All right, so go ahead and pause the video, go ahead and grab and download those. Let's talk about this, right? So three things you got to know about bearings. First thing first, bearings are angles, right? Angles are measures of rotation. So imagine you're here. Well, how do we measure those? Well, we start with true north. North is up on paper, right? Now, which way are you going to measure, left or right? Well, bearings are always measured clockwise from north. So bearings are angles measured from north in a clockwise direction. So with that being the case, what about east? What would be the bearing east? Well, since east and north, well, they're perpendicular, east would be a bearing of 90 degrees. So the three things you got to know about bearings. They're angles, which are measures of rotation. The way that the angles work, they are measured from north in a clockwise direction. They're usually written with 3 digits. Not always, but most of the time. In real life, yes, but on some tests, depending on the writer or the curriculum, this last one's not that big of a deal. But the first two, better keep those in the forefront of your mind. They'll keep you out of trouble. All right, so let's go ahead now and explore how angles and bearings work together. So on the screen, you see the cardinal directions, north, south, east, and west, and northeast, southeast, southwest, and northwest, of course. Well, we already talked about east being 90 degrees, so that's a bearing of 090, but what about the other two? What about south and west? Well, south would be 180 degrees, west would be 270. Now, one thing to be aware of, if you're headed south and you needed to turn west and you're going to use bearings to describe that, you would not say 90 degrees, even though that is going clockwise from 180 to 270. Bearings are always described from north. So west, no matter which direction you're heading, west is a bearing of 270 degrees. What about the others? Well, those would be 45, 135, 225, and 315. Now, a lot of the time they give you a diagram with these kinds of questions, but not always. Sometimes, even if you have a diagram, it's a really good idea to just draw and label the situation anyway. So here we're going to talk about Joseph. He's heading at a bearing of 32 degrees, and we're going to draw and label a diagram that kind of shows his direction, right? So that you start off with just a point, a location, and you draw north because everything's related to north. You measure clockwise, 32 degrees, draw another side, and mark it 32 degrees. That's it. It's pretty simple. What about one that's a little bit trickier? So Geraldine here, she's going at a bearing of 60 degrees for 3 kilometers, and then she's going to change direction and head at a bearing of 45 degrees. What's that going to look like? Well, just like before, start with a point and north. Then you measure to the right 60 degrees, and since she traveled 3 kilometers, we're going to put another point at the end of the 3 kilometers and label 3 kilometers. So changes direction. Heads now at a bearing of 45 degrees. Which is that going to look like, A or B? Would point A or point B lie on her new path? Let me know what you think in the comments. Would it be A or would it be B? Well, turns out it's going to be A. And the reason it's going to be A is because bearings are measured from north, and then clockwise. So it would be right here. Whereas if she was on her trajectory and you measured 45 degrees to the right, it would be down here, but that would not be a bearing of 45 degrees. That'd be 105, right? So if she's traveling at a 60-degree bearing and she wants to go at a 45-degree bearing and she's on this path right here, she would actually turn left by 15 degrees. All right, so now the tricky part. Let's talk about the background knowledge that's required. This is where things get tricky. You can't get zeroed in and locked in on a particular set of formulas or rules or steps. You don't know what you're going to use. The situation's going to determine all the stuff that you know about trig it's on the table. A bunch of stuff from geometry and algebra is too. So you've got all these formulas and more from trig, and you've got, the sum of the angles of triangles, 180. You've got parallel lines and transversals, right? Co-interior angles are supplementary, distance formula, all kinds of stuff. That is where it gets tricky. You're going to have to be clever and creative, right? Don't zero in on, hey, the last problem went this way. This is how they all go. All right. So now let's dive into our first example, right? So we've got Amanda and we've got Michael. I don't know what happened. They were camping, wasn't working out, didn't go so well. They got in a big fight. They broke up. They started leaving in different directions. Michael went at a 35-degree bearing for 7 kilometers, and Amanda, she went due east for 8. They get their relative distances and they cool down. They decide they want to get back together. So how far apart are they? Maybe the walk's too far, not worth it. I don't really know. So first thing you want to do, you want to figure out what is it you're really being asked to find out. Can you draw it? Well, wouldn't that be it right there, the distance that they are apart? And that is, of course, the side of a triangle. So we now know for sure exactly what we're looking for. So what are our clues? A couple things. Amanda went east. Well, that's perpendicular to north, so that would make a 90-degree angle. And since I know that Michael went at 35 degrees, I can figure out that this one right here is 55 degrees, right? I also know these distances. So I have two sides and an angle. I need to know the distance of the side that's opposite to that angle. So if I look at all of the stuff I have for trig, this is actually the trickiest part. You might be good at using each of these, but in problems involving bearings, you're not going to have somebody telling you, hey, use this one. So you have to be really well versed in what they mean. So if you look at this rule right here, right, if we know an angle and its opposite, or one of the two, we know the others, this is what you use. So we have two sides, right, B and C, the included angle, and we need the opposite side. That's that one right there. So write it down, plug in your numbers, do the math, 6.98 kilometers apart. That's it right there. So now let's talk about some steps you can follow, some kind of guidelines to keep you out of trouble, right? So first thing you're going to do is you're going to read it and then you're going to figure out, hey, what exactly am I being asked to do? Can you say it in a different way? Can you draw it? Do those things. Then figure out what clues do you have. Almost never are you going to be given distracting information or extra information. Pretty much everything they tell you, you're going to need. Then what formulas are available to you? What facts do you have, right? Write down the formula, plug in the numbers, figure out if you're missing something, go back and find that information, and then do the math. Write down your final rounded answer and verify it. Does it make sense, right? So those are the steps that you're going to use with these kinds of problems. So let's go ahead and try those steps in example number 2, shall we? So we've got a ship. It's sailing from a harbor that's spelled in the fancy British way with that extra U. Anyway, the harbor's at H. The ship leaves at 84 degrees. The bearing of 084 for 340 kilometers till it gets to P. Then it turns 210 degrees for 160 kilometers till it gets to Q. Calculate the distance between Q and the fancy harbor, right? Well, first thing first, we're going to identify the question. What is it we're being asked? We're being asked to find that distance right there, right? What are our clues? Well, we've got a few, right? It gave us a couple things. We know that two of the distances, 340 and 160 degrees, we have or kilometers, and we have a 210 degree bearing right here. So those are the clues we have. So what formulas can we use? Well, this is kind of tricky. It's not entirely obvious yet. Let's see. Typically, we got sine rule, cosine rule. Those are the two we're probably going to end up using because I doubt this is a right triangle. Well, to use the sine rule, you have to know at least one angle. We don't know any. We do have these two sides. We need the third. I would say that the cosine rule is going to be the way to go, right? Let's plug in our numbers and see where we're at. Right? So we know 340, we know 160. We also know that the side we're looking for is opposite of this angle. So that's the side. That's the angle A, the question mark. We have to figure out this before we can use the formula, right? So how can we figure out that angle? Well, North is parallel to north, which makes this side from H to P a transversal. And maybe you forgot, but if you have two lines that are parallel and you have a line that cuts across them, that's called a transversal. Those angles created like that, those are called co-interior. They're supplementary, right? Well, if they're supplementary, then this angle is 84. This one has to add up to 180 with it, so it's going to be 96 degrees. All right, so now we know that 96 and 210 and this thing with the question mark, they have to make 360 degrees because that would be a full circle, right? So if we just do a little subtraction, we find out that the angle we're missing is 54 degrees. Now, we can plug that 54 degrees into our cosine rule and plug all that into the calculator, get 277.93, right? A lot of numbers. So a lot of the time it's a good idea to write down your unrounded answer, but then as your final step, write down your rounded answer. So we found out that the length would be 278 kilometers. Well, let's see if that seems reasonable. So here's the thing. With a triangle, the smallest side is opposite of the smallest angle. So if this angle right here is smaller than 54, then because 160, which is opposite of this angle, is smaller than 278, we probably have a pretty reasonable answer. So let's go ahead and find this angle right here. Now there's a couple ways to do that too, right? We could very, very easily use the sine rule because we know this pair, right? This angle and its opposite, and we're looking for this angle to have its opposite. But I decided for this case, we're going to use the cosine rule for the missing angle. It doesn't really matter which one you use. You're going to get the same answer anyway, either way. So we plug in the numbers, do the math. We're going to find out that this angle right here, A, is 28 degrees. That is significantly smaller than 54 degrees. And 54 is opposite of 278. 28 is opposite of 160. That seems like a very, very reasonable answer. So to wrap up, these are the 5 steps you're going to follow every single time. You're going to identify the question, look for the clues, write down your formula, make sure you got all the parts. You might have to go back and look at more clues to figure out some things. Then you're going to do your math, write your rounded answer, and verify. Hey, if this was useful to you and you found that it was a very good learning experience, do me a favor. Let me know. Leave me a comment, like, share, subscribe, all that kind of cool stuff. And if you are a math teacher, check out my Substack. I have a weekly math problem just for fun. It's a challenge problem. I post them in my classroom. It's kind of fun to see the kids do it. They do it just for fun because it's a puzzle, not because it's classwork or anything like that. My website got all kinds of resources for teachers. I also have a Teachers Pay teacher store. Links in the description for all that kind of stuff. Hey, till next time, hope you have a great day.